here's an example problem, and I'll show you how I write them so that I can kind of keep track of where the information is. Now, I am going to have to make another factor label in just a second, but I'm going to put my reaction up here at the top so we've got a little bit of space underneath it. So what's the percent yield on this problem? So we have 2 sulfurs plus 3 oxygens go to 2 SO3s. And now we're told that we have 10 grams of this, 10.0 grams, and this is excess, so this one won't matter. And then over on the right, it's going to form some of this. So that's what we're trying to get to. And this is going to be in grams. When we figure this out, this is what mathematically, that's the key word, right? If you do math, that's going to give us our theoretical yield. You'll notice that this wasn't given in the problem, that you have to do math to do this. Okay, now the problem will have one extra piece of information. Here's the first piece of extra information. The student actually produced this much. So what that means is they did this whole reaction in the lab, and then they got a product and they went and they put it on the scale, and then this is what the scale said. So this is always going to be after reaction. It'll say something like, some of the keywords would be like the student actually produced, or after the reaction finished, the product was put on the scale, that kind of information. Those are words to tell you that that number is the number that they are. Now, it'll be usually within the problem. It won't always be so much A, B, C, D. So I'm going to make a little note here. We don't know the theoretical yield, so that's one thing we will have to solve to do this equation, because the theoretical yield, that's this bottom section here. The other thing is we have to put the actual on top once we have it. So this is how something like this will look. If this is part of the problem, a lot of people will put their numbers like this. And this is perfectly fine to do this. This is a good sign. If you have a number here in the problem given to you and a number here, that means that it's going to be an actual percent yield problem. And I know that because problems just never give you the theoretical yield. So you have to calculate the theoretical yield first, and then you're going to put it into the percent yield equation. So first I need to calculate, and I'll use a different shade, or I'll switch it over to black. So if I have 10.0 grams of sulfur, I'm going to go from, and thankfully it's in here, grams of sulfur to moles of sulfur. And then I'm going to go from moles of sulfur to moles of O2. Oh, SO3, sorry, SO3. That's what we're wanting to know about. I'm going to go from moles of SO3 into grams of SO3. Now, this is 2 to 2 based on the coefficients. So we've got this coefficient here on the left. It's a 3. I keep grabbing the oxygen. On the left is a 2, and that's in front of the sulfur. And then we have this coefficient over here on the right, and that goes in front of the SO3. And then we grab in the rest of this from the problem. But if it wasn't in the problem, you would get this from the periodic chart. It's just trying to save you a little bit of time. So 37.07, 32.07. And let's see, it's wanting to know the trioxide. So that's 80.07. This reaching 1 mole. So we'll do this calculation first, and that'll be the lower part of our theoretical yield. So clear, just make sure it's showing. All right, 10, I'm going across the top, times, and you know, if you didn't want to put these in calculator, that's a 2 and a 2. You can put them in, but really those cancel out. So it's like saying 10 times 1 times 1 times 80.07 divided by 32.07. Oh, I accidentally put 2 times in there. And so that gives me 24.97 grams. And that's what's going to go on the bottom right there, the 24.97 grams. Now the actual was given in the problem, and that's going to be really normal. Your actual will be given in the problem. And so in this case, it's 1. So I'm going to move my math right down here so that you can kind of see it right in here. If I use a blue, so it's actual, that's the actual, over the theoretical, that's 24.97, times 100% gives me 1 divided by 24.97 times 100. Looks like it's 4.00%. Now let's try it for the next one. 24.97 grams. 4 divided by 24.97 times 100. That's a really nice yield comparatively. Don't forget the times 100. 96.1112%. And then let's try this one. 30 divided by 24.97 times 100. Don't forget the times 100. If you get a really low number, double check it. So when I do this one, it comes out to be 120.14. This is like saying, I have enough ingredients to bake 2 dozen cookies. So when I got done, I had 10 dozen. Is it possible to ever make more than your theoretical yield? No. What's really common, though, is because these reactions are done in water, you don't wait for it to dry. It'll kind of look dryish, and people don't wait. And so they end up, basically, it's like weighing a wet towel instead of a dry towel. It makes it really heavier. And so if you don't wait, it will be extra heavy. So always be suspicious if you get more than 100%. Be suspicious if you get 100% too. This is a very low number. Probably what I would say if this were a reaction I was trying to figure out for someone, probably what they did was they did a little bit of reaction, and like I would have guessed that maybe they picked up the wrong jar or the wrong chemical after their reaction and then put that on the scale. That's where, because that's a really low yield. Most reactions aren't going to be that low. And if they are, then they probably won't be considered for any future use.